Alright, I'm going to review graphing quadratics in standard form. Now again, standard form is y equals ax squared plus bx plus c. In standard form, there's a place that we're going to start, but there's a very, very important formula you're going to need to know. So we're going to start with the axis of symmetry, and the piece you need to know is x equals negative b over 2a. This is very, very important. It's something you need to know when we're dealing with quadratics. So it not only works with standard form, but there's a few other problems that negative b over 2a is important with. So to start with the axis of symmetry, we need to do negative b over 2a. So I'm going to go up to my problem. I already have my negative. My b is just 8. And I'm going to have 2 times a, and a is negative 4 in this problem. So I have a negative 8 in the numerator, and the denominator, I'm going to have 2 times negative 4, which is negative 8. Negative 8 divided by negative 8 is 1. So our axis of symmetry, it's always written as x equals, it's going to be x equals 1. Now remember that axis of symmetry, that's going to give us kind of that line of symmetry through our parabola. That'll come into play here in a little bit. Once you know the axis of symmetry, you actually know a piece of your vertex. Because what happens is the x value of your axis of symmetry is also going to be the x value of your vertex. So we know this is x equals 1, so we know the vertex has an x value of 1. So we'd like to find the y value of the vertex. If you ever know an x and you want to know a y, all you have to do is plug it into your original problem. Plug in x and you'll get y. So if I plug in, I'm going to have y equals negative 4 squared plus 8 times 1 plus 2. So all I did is I replaced my x's with 1. So 1 squared is 1. 1 times negative 4 is negative 4. 8 times 1 is 8. And then plus 2. Negative 4 plus 8 is 4. 4 plus 2 is 6. So I know my y value is 6. So once I know my vertex, I'm going to go ahead and plot this. So we're going to go to x equals 1, y is 6. Now again, remember we already know our axis of symmetry. It goes right through our vertex. So there's that piece. Next piece we'd like to get is we'd like to get a y-intercept. Now if you ever want to find a y-intercept, you just always plug x equals 0 in. So if you want to find a y-intercept, you make x 0. If you want to find an x-intercept, you make y 0. It's always the opposite there. So I'm going to plug in x equals 0 into my problem, which is off the page now. But it is going to be y equals negative 4 0 squared plus 8 times 0 plus 2. 0 squared is just 0. 0 times negative 4 is 0. 8 times 0, 0, then plus 2. So 0 plus 0 plus 2, you get 2. So if we go back up to the top on my graph, we look for, hey, where's a y-intercept at 2? It's this point. And we could write that as a coordinate. So I'm going to write that as 0, 2. Last thing you need to do is just mirror and use that line of symmetry there. Mirror it over and you get this point right there. Once you have 3 points, you can draw the curve and make your parabola. That's graphing quadratic in standard form.